This is an example of long division, where we're dividing a binomial into a polynomial. The original polynomial we were dividing into was 9x to the third plus 5x minus 4. You need to have a zero coefficient on the x squared term as a placeholder. The first question we ask ourselves is, how many times does 3x divide into 9x to the third? In other words, 3x times what equals 9x to the third? The answer being 3x squared. Notice I put this squared term over the other squared terms. Next, we take 3x squared, multiply by the entire 3x minus 1. 3x squared times 3x is 9x to the third. 3x squared times negative 1 is negative 3x squared. And just like in third grade long division, we are going to subtract. So that's a subtraction symbol, not a negative 9. 9x to the third minus 9x to the third zeroes out. 0 minus 3x squared. The minus minus is like a plus, so we have positive 3x squared. And we bring down the plus 5x. And we ask ourselves that same question again, but this time, how many times does 3x divide into 3x squared? The answer, 1x times. Then we multiply. X times 3x is 3x squared. And you can see how that 3x squared is going to cancel out again when we do our subtraction. The x times the negative 1 is negative x. Let's set up the subtraction. 3x squared minus 3x squared is the 0. I'm not going to write it this time. And the 5x minus x is 6x. The last time we're going to bring a value down is we'll bring down the negative 4. Ask ourselves 3x into 6x. That happens positive 2 times. And we multiply the 2 times the 3x minus 1 gives us 6x minus 2. We do the subtraction one last time. Negative 4 minus 2 is like negative 4 plus 2, which equals negative 2. And a little bit unusual in this circumstance, we are going to take the negative 2, which is the remainder, and we bring it all the way back up here to our quotient, and we write plus the negative 2 value, and we make sure still to divide it by our divisor of 3x minus 1. This is, and that needs to be a negative 2 in the numerator up there. Everything that's up here is your final answer for the division problem.